Hey friends, welcome to the lecture on base system from winningnotes.com. In this session we are going to talk about what do we mean by base system and or rather like what are the various kinds of number systems. So you would be aware or you would have already heard about the decimal number system. And do you know like what do we mean by that? A decimal number system represents the digits from 0 to 9. Now you will say that no, there are the counting lasts till many digits या counting हम बहुत आगे तक कर सकते हैं, infinite तक digits होते हैं. But ऐसा नहीं है. When we talk about digits, we talk about single numerical symbols which are used to represent the numbers. So 0 to 9 are the various digits that we use, because the moment we write 10 or the digits 1 0, we are repeating 1 and 0. And also if you notice from 0 to 9, if you count these digits, they will be 10. And decimal we know means 10. Hence, decimal number system has got 10 different digits from 0 to 9. Similarly, we can also say that this number system has got a base of 10. In the same manner, for the other kind of number systems, say like binary, we will have only 2 digits. Bi means 2, and hence the base also for this number system will be 2. What are the various other kind of bases? Now we can have binary, septenary, octal, decimal, duodecimal and hexadecimal. Or there can be some other kind of number systems also, but these are the main number systems which are asked for in the examination. Now septenary, wherein sept means 7, has got 7 different digits from 0 to 6. Octal has got 8 digits from 0 to 7. Decimal we already know. Duodecimal actually means that the number system has got 12 digits. Now how do we represent the 12 digits? We know that 10 digits can be represented from 0 to 9, and after 9, for representing the 10th digit, we will use the alphabet A. For 11th digit we use alphabet B. Similarly, for the hexadecimal numbers, we will use 0 to 9 for the first 10 digits and alphabets A to F for the next 6 digits. Now you are aware of the various number systems or the various bases. Now let us see how do we convert from one base to the other base, because these are the kind of problems that you will have in your exam or in the questions. Now suppose any number can be represented as x dot y, where x is the integral part or that part which comes before the decimal, and y is the fractional part or that part which comes after the decimal. So the number can be say like 10.237. Okay. Now in case x dot y is in a decimal base, then let us see how do we convert it into a non-decimal base. Now because the number is in a decimal base, hence the digits can be 0 to 9 only. So let's say x will be a number between say 1 to 9, because 0 cannot be represented over there, and y can be a digit again from 0 to 9. To convert this x dot y, you take x first, or you take the integral part first, and keep on dividing this integral part by the base n, which is the base of the non-decimal number system in which you want to convert it. So अगर हमें इसको बाइनरी में कन्वर्ट करना है, then you will keep on dividing this integral part by 2, and whatever numbers or whatever the quotient comes, you will keep on writing that from say on the rightmost side. Alright, so write the first quotient on the rightmost side, then write the next quotient immediately on the left to that, the next quotient immediately onto the left of this second quotient, and so on, till the time you reach a remainder wherein the remainder is less than n, or in this case the remainder is less than the digit 2. Once you have done that, because you are already writing the first quotient on the extreme right, now what you will have is a series of numbers from left to right, and this is how the integral part of the new number system will be represented. Now let us see how you will convert the decimal part into the non-decimal number system or the fractional part. Now take the number y, which is the fractional part, and multiply the fraction by n, and then the whatever result comes, then again multiply that by n, whatever result comes, again multiply that by n, and you have to keep on doing the same till the fraction value becomes 0 or it becomes non-terminating. Now keep this in mind, हमें किसी भी डेसिमल नंबर सिस्टम को अगर नॉन डेसिमल में कन्वर्ट करना है और वो डेसिमल में x डॉट वाई में लिखा हुआ है, तो आप x को लीजिए, उसको नॉन डेसिमल नंबर सिस्टम का जो बेस n है उससे डिवाइड करते चले जाइए और जो भी क्वेश्चन आएगा उसे राइट मोस्ट से होते हुए लेफ्ट 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 करते आप लिखते चले जाइए, तब तक डिवाइड करते जाओ जब तक कि आपका रिमाइंडर उस बेस से कम नहीं हो जाता। और जब आप इसका फ्रैक्शनल पार्ट डील कर रहे हो तो आप उस फ्रैक्शनल पार्ट को n से मल्टीप्लाई करते चले जाओ जब तक कि जो बैलेंसिंग फिगर है या जो कि रिजल्टिंग फिगर है वो ज़ीरो नहीं हो जाती या फिर वो नॉन टर्मिनेटिंग नहीं हो जाती। सो व्हाट डू वी मीन बाय नॉन टर्मिनेटिंग? नॉन टर्मिनेटिंग वुड मीन दैट द डिजिट्स ऑफ दिस फ्रैक्शन आर डिफरेंट एंड दैट दे विल कंटिन्यू टू बी डिफरेंट। द मोमेंट दे बिकम terminating, which is say like you start getting 0.1212121212 and it keeps on happening like that, then you stop at that moment. Now let us see an example. So in this case we are trying to convert 12.34, which is in decimals, into the binary number system. So here x is equal to 12 and y is equal to 0.34. We divide 12 by 2 and keep writing the remainders in the backward order. So in this given chart you can see that we are dividing. The first remainder is 0 when you divide 12 by 2. Next, when you get the quotient as 6, you divide that again by 2 and you get again a remainder 0. Similarly you keep on doing the same till the time you get the number or the quotient as 1. Now we know that 1 is less than 2, hence we have to stop here and we have to start counting backwards. So which is, we will write the number as 11000 in a binary form, or otherwise we could have written 0 on the rightmost side, next 0 on the immediate left, next 0 on immediate left, and then write 1 and 1. So this was a little bit easy part. Now let us see how do we convert the 0.34 into the binary form. We said that this is in the form of point y and you have to multiply that by 2 and keep noting the integer. So let us start. The integer in this case is, the fraction is 34, we multiply that by 2, we get 68, integer is 0 because there is no quotient coming from this fraction. Next you multiply 68 by 2, you get 136. So 36, which is 2 decimal points, will be the fraction and 1 will come as the integer. You again multiply that now 36 by 2, you get 72. You multiply that 72 by 2, you get 144. So 144 mein 1 is the integer and 44 is the fraction part. So you keep the fraction part over there. If we keep on doing like this, you will see that we are going on and on and on. Hence we can stop at a certain level. It is non-terminating. It is not going to terminate because somewhere or the other you will keep on getting a product. So we can stop here and we write it like in the simple manner. वहाँ पे हमने backward लिखा था, here we will write in the straightforward manner. So first integer being 0, after decimal you put 0, then 1 0 1 0 1 1 1, and you can end it over there and this will be again in the decimal form. So the result that we get is 12.34 in the decimal form is 11000.010101111 in the binary form. Remember this. Divide the first part by the new number system, multiply the second part by the new number system, and continue the first part till you get the remainder or the quotient less than the number system's n base, and you multiply the second or the y part with the base n till the time you get to a non-terminating, or if you get to a 0 as the quotient. So in our previous topic we spoke about how to convert a non-decimal base number into a decimal base number. Now let us take an example. So we have a number 101 decimal 10 and we have to convert into decimal base. and the original base of this number is binary. Now as per the formula, we take the part x, which is the integral part, and we take the rightmost digit, which is 1 in this case, and we multiply that 1 by 2, and 2 will have a power of 1 minus 1. 1 minus 1 happens because this digit 1 is on the first place, or it is on the units place. For units place we will take the power as 1 minus 1, for tens place it will be 2 minus 1, for hundreds place 3 minus 1, and so on. Similarly, the second digit is 0, which is at the tens place, hence we will multiply that 0 by 2 raised to the power the place at which the 0 is there in the original number minus 1, which is 2 minus 1, and so on. So we get the resultant as 1 into 2 to the power 0 plus 0 into 2 raised to the power 1 plus 1 into 2 raised to the power 2, which is equal to 5. Now let us take the decimal part, which is 0.10. As we said earlier, so we will take the first digit, which is 1, and we multiply that by 2 raised to the power minus 1. As we move from decimal to the rightmost side, we have to keep on raising the new base number or the original base number raised to the power minus 1 for the units place, minus 2 for the hundreds place, and so on. Hence the resulting number we get by converting decimal 10 is 0.5. Combining these numbers together, we get 101.10 in a decimal base is equal to 5.5 in a decimal base. Now how do we convert from non-decimal bases? For binary to octal, which is when we have to convert any number from a base 2 into a number with base 8, we take it the original number as groups of 3 digits of binary and replace them with 1 digit of the decimal number. From octal to binary, we replace 1 digit of the octal with 3 equivalent digits of the binary number. If in any case 3 digits equivalent are not there, then we put 0 on the left hand side of the number and then make it as a group of 3. Similarly, from binary to hexadecimal, we make or replace in terms of groups of 4. So it is pretty simple. A hexadecimal number is actually represented as a number of 16 digits, which is 2 multiplied 4 times. Hence we group it in the number or in the groups of 4. An octal represents the number 2 multiplied 3 times, hence we convert that by making groups of 3. Let us have an example of converting this number which is in binary form into the octal form. As we make groups of 3, remember that we have to make the groups of 3 starting from the rightmost digit. So we have 101, then 010, then 110, and finally 1. Now we know that on the left hand side this digit does not have a group of 3 digits, hence we add 2 zeros to it. After that we will simply convert this into a binary number. Now 001 represents 1, 110 in binary is 3, 010 is 2, and 101 in the decimal form is 5. And then we combine those numbers, which means 1325, and the same number is the representative form in the octal. Now remember that even if we are converting this binary number originally into decimal forms, but you will never get a number which is beyond, or you will never get a digit which is beyond 7. Why? Because 111 would mean 7 in decimal as well as in octal, and the digits 0 to 7, whether they are in decimal or whether they are in octal, that would represent the same when we convert it. Now we can do some arithmetic on these numbers. Arithmetic basically means that we will apply the formula for addition, subtraction, etc. This is sometimes asked in the question papers, and hence it is important to know. Now in binary, 0 plus 0 is 0, 0 plus 1 is equal to 1, 1 plus 1 gives you 2 in decimal, which is equivalent to 10 in binary, and 1 plus 1 plus 1 gives you 11. Now you add 101 plus 111 in binary and you get 1100. Let us see how it happens. This just happens because you keep on adding. Take the units place, you have 1 and 1. If you add them it gets you 10. So we write 1 in the units, we write 0 on the units place, and 1 is carried forward. Now we have 1 as carry forward plus 0 plus 1, which again gives 1 plus 1, which is again 10, and we put 0 over there in the tens place now, and 1 is again a carry forward. Now we have 1 plus 1 carry forward, which is 11, and then we put 11. Hence we get 101 plus 111 is equal to 1100 in a binary form. If we have to do a subtraction, then how do we do that? We have to remember that as we carry forward in decimal, we subtract the higher number from 10, the smaller number. Example, when we do 54 minus 6, we carry forward 10 from the tens place, which is from 5, and make it 4 as 14 at the units place, and then we subtract 6 from that. Similarly, for binary, in this example we will carry forward 2. Remember that we are carrying forward 2 and not 1 from the hundreds place, because we do not have a number which is sufficient in 101101, and when we are subtracting 1011 from that, so at the hundreds place or at the tens place we have got only 0. Now 0 minus 1 is not possible, hence we carry forward from 1 at the hundreds place. The moment we carry forward 1 or rather 2 from the hundreds place, we get at the tens place the number 2, and then we do 2 minus 1, which gives us 1. So it is pretty simple. The way in a decimal number, when we carry forward, we add 10 to the number to which it is carried forward. Similarly, in case of a binary subtraction, we will carry forward the number 2. So remember that we carry forward the base itself to the new number, we added to that, and then we subtracted just the way we will do in a decimal form. So we hope that you would have liked this chapter on the base system and it will be of help to you. In case you have any queries, you can log into winningnotes.com and have those resolved for free. There are some other courses which we offer, which are into CA coaching, MBA entrance, soft skills, etc. And we do hope that you will make the best use of it. All the best, friends. Take care.